In this video, we're going to answer the questions 6 through 8 for the propane question. They say, draw the energy diagram for this reaction using the theoretical value you calculated. Do the reactants or the products have more bond energy? And if the mass of water in the aluminum calorimeter is 750 grams at 20 degrees Celsius and the mass of propane burned is 2.50 grams, what is the final temperature of the water? Assume the burner is on for 30 seconds. Sketch a graph of water temperature versus time. Okay, so the first thing they want is they're wanting a graph of the reaction. So our EP, it's going to step down because the enthalpy that we calculated using Hess's law was negative 2043.9 kilojoules. That was for 1 mole of propane and 5 moles of oxygen and 3 moles of carbon dioxide gas and 4 moles of water vapor. And so the reaction occurs over time. So this would be our graph, and this is going to help us decide whether the reactants have more more bond energy or less bond energy. And bond energy is kind of like potential energy. So if we've got more potential energy, there's more bond energy in the reactants than the products. So the bond energy of the reactants is greater than the products. And so that answers questions 6 and 7. The one other thing I thought I'd mention, though, is right now I haven't labeled anything on this graph. If this happened to be labeled as 200 joules at this point, the number up here would be what? Well, this would be a number that is stepping down to here. So it'll be the 2043 is the difference between these. And this number should be bigger, right? And so if you had negative 2043.9, you want to be left with 200, this would be, this would be 2,243.9 kilojoules, and the difference is the negative enthalpy, right? And so sometimes they will label here and here instead of giving you this value. And so you have to determine what the enthalpy is by reading the y-axis of the graph. Thought I'd just mention that because sometimes that comes up, and because we don't see that often, people are looking for that. Next question had said, if the mass of water in the aluminum calorimeter is 750 grams and you burn 2.50 grams and the temperature of the water starts out at 20 degrees Celsius, what is the final temperature? So the number of moles times the molar enthalpy is the Q value. Q is also equal to MC delta T. Well, if I wanted to solve for delta T, I would have the number of moles times the molar enthalpy divided by MC. Well, my N value is mass over molar mass of the propane that is burned. So the mass of my propane is 2.50 gram, and the molar mass is 44.01 gram per mole. And so 2.5 divided by 44.01 gives me 0.0568 mole. And so 0.0568 mole of propane times the molar enthalpy of negative 2043.9 kilojoule per mole will be divided by the mass. Now we have two masses, but this is the specific heat capacity of water. And so this needs to be the mass of the water. So it's going to be 750 gram. Now, when I'm sorting this out, you'll see that my grams cancel and my moles cancel and my joules cancel, but this gives me kilo degrees Celsius. So I either need to convert this to joules per mole, or I could instead make this 0.750 kilograms. My grams still cancel out, but then my kilos do as well. So I'm going to put that into my calculator. And the change in temperature should be 36.9 degrees Celsius. Now, the change, though, is because of an exothermic process. So this is how much hotter the water is than it was before. So the T final is going to be 20 degrees Celsius, 20.0 degrees Celsius plus 36.9 degrees Celsius. I just like to keep track of what's happening with endo and exo and temperature change, and kind of do that separately than worrying about my pluses and minuses all the time, because it's easier for me to get turned around at some point. So hopefully that helps you understand how we approach that question.